we're going to talk about centralized monitoring and troubleshooting for Kafka clients. So this is all about KIP 714. So I'll kind of explain what that is, and we can get into what it's all about. So a KIP is a Kafka improvement proposal. This is one which was initiated probably 3 years ago, something like that. It was quite a big KIP. And it's all about trying to get rid of this operational gap with client performance. So there are plenty of companies where you have a kind of a central team which is operating the Kafka clusters, and they're divorced from the application teams who would actually write the applications and tune them and all this kind of stuff. And they really struggle today to work out what the clients are doing, and they sometimes find that there are performance problems that they don't understand. They've got no way of chasing them up. So KIP 714 is essentially all about that. It's about centralizing the client metrics so they can be analyzed and kind of correlated with the broker metrics in order to troubleshoot. If you've got a single Kafka client application, you don't need this KIP, right? It's not worth it, because you can access the metrics directly. But if you have 10 of them, 100 of them, 100,000 of them, you probably do need this KIP. KIP 714 was introduced in Kafka 3.7, which was in February this year. It was then improved to 3.8, so if anyone was going to start using it today, I would probably recommend starting with 3.8 instead, but it came in 3.7. And the important part of that is when you introduce a new feature into Kafka and it has client and broker changes, it takes forever for the clients to roll out, because of course you have to touch every client application. So older clients have it, and the fact that the clients were fixed in February 2024 means there's been a reasonable amount of time for them to roll out, so you can get the data from them. So I'll give you a bit of an idea of the difference between the client and the broker metrics, and you'll see kind of why it's important to have the two sides of the coin. So clients record a lot of metrics, so more than 100 metrics in a client, so a hell of a lot actually. And they include things like the network behavior, kind of the latency for sending data to and fro, how many bytes are being sent, how long it takes to do it, whether authentication succeeded or not, and stuff like how the memory is being used in the producer, and how frequently data is being committed by a consumer, how often it rebalances. So those are ones the clients actually record for themselves. So if you want to understand the client's view of performance, you need to ask it. That's what the KIP is all about. And the broker, in comparison, it maintains kind of high-level metrics. They're kind of aggregate things, but in general, it'll be things like how many requests I've received across the whole client fleet. And the stuff like replication and rebalancing, or not, when the leadership of partitions changes, that kind of stuff is recorded by the broker. So if you wanted to, for example, if you had client performance that was generally okay, and then every now and again one of the clients went bad, if you were able to get the client metrics and the broker metrics together, you might be able to find some kind of correlation, like perhaps a broker fails, and it's the recovery from the failure of the broker which causes the client performance to dip. So that's why you might want to put them all together, so you can see that kind of correlation. So let's talk a little bit about client metrics today. So Kafka clients collect, I say copious metrics here, that's probably an understatement. A hell of a lot of metrics. They count everything. And, excuse me, if you know what you're doing, then you can readily access them. Excuse me. But they were designed with knowledgeable users in mind, I suppose, right? So that on the right-hand side is an example from the Kafka client documentation. Okay, it's just a big table of metrics, but the way they're described to you is really quite complicated to understand. There's this thing called MBean name. Almost nobody knows what an MBean is. It's a kind of a part of a Java standard for management, and they have names, and they have kind of compound names. So it's a multi-part name. A little bit difficult to get your head around if you're not used to JMX. So actually reading the documentation is your first battle. If you're doing it as actually an application programmer, and you've read the Java doc for a Kafka consumer, then you'll notice there's a kind of a slightly peculiar method in the Kafka consumer interface called metrics. And it basically gives you a list of all the metrics in your client, and then you can dive down into that and get particular values. So if you're an experienced user, you probably have everything you need already today. But if you're not an experienced user, it's kind of a bit difficult to get started, I think. So the way the clients report metrics is using what's called a metrics reporter, unsurprisingly. And there's a default one. You can configure your own if you want to, but there's a default one configured using a technology called JMX. And JMX is probably the easiest way to actually interrogate the client metrics if you've actually got a client running on your laptop, for example. So you could use a tool such as JConsole, and JConsole lets you browse the metrics on your client. So if you were running with a single client on your laptop, trying to tune it or something like that, what I would do is I would start it up, I would make it run for a little bit, I would then type JConsole on a command line, I would find the client that I was playing with, and then I would go in there and navigate through the metrics and get a picture of it then. Which is fine for one client, but as I said, if I have 1,000 of them, it doesn't work anymore. And the picture on the right is a view of what JConsole looks like, and you can see all the metrics on the right-hand pane of it, and you can see how they kind of correlate to that little snippet of the documentation on the left-hand side. So let's talk about KIP 714 and what it does. So it's called Client Metrics and Observability. This was a very, very painful KIP. It took 2.5 years from its initial writing to getting voted. It was pretty controversial, and it took lots of twists and turns before it finally landed. But this is what it turned into. It gives you a generic and standardized interface for collecting client metrics. So what that means is it's a slightly unusual KIP in that it allows extensibility beyond Kafka itself. Okay? So it tells you how you could collect metrics from other systems, such as, for example, libRd Kafka. So this is actually a framework for doing cross-platform metrics correlation on the brokers, not just Java client metrics, and that's quite important. And the way it works is clients push metrics to the brokers, okay? So the Kafka protocol, which is how the clients talk to the brokers, has been enhanced by this KIP to have this idea of pushing metrics from the clients to the brokers. And it does this based on a subscription. So a subscription is effectively the broker says, I'm interested in metrics A, B, and C. And that's the subscription that goes down to the client. The client goes, oh, you want A, B, and C. It collects them, and then it pushes them periodically up to the broker. So that's the fundamental kind of technology behind it. Then you have to have a plugin on the broker to handle the metrics, because they have to go somewhere, right? You know, if you send them up to the broker and it's got nowhere to put them, then you haven't achieved anything. So you have to have a broker which has a plugin installed within it, and the plugin, that's the thing that actually pushes the metrics somewhere where you can do your analysis or whatever, or your storage. And then it defines a set of what they call is standard and required metrics in the KIP. Okay, so this is how the cross-platform metrics work. So it says, here's the name of a few standard metrics or required metrics. Any client that supports 714 has to be able to support these. So an example would be producer node latency, okay? How long it's taking for a request to go from the producer to the broker and back again. You calculate the latency, that's one of the required metrics, because anything that sends a produce request to the broker is going to be able to do it. That concept is universal. So the universal concepts have standard names, so you can collect them from every client on the planet which supports KIP 714. Then it uses, as its encoding technology, it uses a thing called OTLP, which is the Open Telemetry Protocol. Okay, so this is a standard in kind of metrics circles for doing this sort of thing. So we didn't invent a new way of encoding metrics as part of the KIP. We used a standard one. So the data flowing from the client to the broker is in this OTLP format. And lots of the metrics backends understand OTLP, so you can send the data onto it without having to parse it and fiddle around with it, right? So it gives you a kind of a natural way to do this kind of thing. And then finally, it's enabled by default on the clients and disabled by default on the brokers. Okay, so the first part of that is really important, because what I was saying was it's for teams where the client and the broker are kind of operated by different people. So you can't go around and say to every application team, could you just turn on this setting for me, please? it's kind of impractical to do that. So that's why it's turned on by default. But on the broker, it's turned off by default. So that means it's kind of benign until you turn it all on, and then all of a sudden it all leaps into life. So it's designed to have no footprint unless you actually turn it on. So let's have a look at the architecture. Initially, of course, you've got a set of brokers, which are your cluster, and then some clients. And then I said that in order to turn all of this on, you need a client metrics plugin. Okay, so that's the plugin component. So this is a piece of Java code which you compile and put into the class path of the broker and then configure it. And it supports an interface called client telemetry, and that says, this broker now understands how to do KIP 714. There's also a kind of a database of client metric subscriptions. So this is effectively the list of which metrics are needed from which clients. So this is stored actually in the metadata log on the brokers, and then available to every broker in the cluster as a result of that. So if that is empty, if there's no client's metrics to subscriptions defined so far, no metrics are collected. Okay. So what you then do is use a tool. So the KIP defines a new one called Kafka Client Metrics, and then you create a definition of the metrics to be collected, and that inserts it into this subscription table. And having done that, then the broker is now kind of interested in collecting metrics. When the client connects to the broker, it does an initial handshake, and if you know the Kafka protocol, you understand there's a lot of kind of handshakes between the two ends. It says, what version are you, what kind of client are you, it authenticates, it gets metadata, and it adds another initial kind of RPC to this flow called client telemetry subscriptions. So the client says to the broker, do you want any of my metrics? And it gets back a list of the metrics which are required, which may be empty, in which case nothing gets sent. Okay, and then when it's got the list of subscriptions, then it will periodically push the telemetry using this OTLP format from the client to the broker. Okay, so we've now got the data flowing from the client to the broker. Now we have to do something with it. So then what the client metrics plugin does is it will generally pass it to an external metric system. Okay. And that will depend on your own environment, right? Everyone will use a different kind of environment for doing that sort of thing. If you were writing a kind of a trivial one, and this is what I did when we were testing it, then it will just print a log line, or it'll say, somebody sent me this metric. So you can see it's at least working, but it's no use to anyone just doing that. And there are some subtleties in here as well. So one of the things people understand if they get into how clients work is a client will often collect to multiple brokers, okay? Any one of the brokers can connect the metrics, okay? It could be all of them, right? It's allowed to send to any of the brokers. It will typically send to a consistent one, but if the broker that you're connected to, stops for some reason, it gets restarted, then the metrics will get effectively redirected to a different one instead, and the flow of metrics continues. So it's not a one-to-one connection, it's a one-to-many connection in order to achieve that. So now I'll kind of get into some of the more tricky things. This is an indication of why it took quite a while to get the KIP agreed. And I think I'm pretty happy with where it ended up eventually, but it took a while to get there. So let's say you have a 3.6 cluster. You're using Kafka 3.6, and you upgrade to Kafka 3.7. Is this all going to leap into life and start using an enormous amount of my resource? Well, the answer is no. Okay. If you don't have a client metrics enable plugin, nothing happens at all. In fact, the broker will deny it even knows how to do this, right? So when you do the initial kind of exchange of information, and one of the things is called an API versions flow. It basically says, which packets do you understand? The client asks the broker, and it will deny it knows how to do push telemetry if it doesn't have a plugin installed. So no plugin, no dice. It just doesn't work, okay? So if you configure a client metrics plugin, will the cluster then get flooded with metrics? Well, again, no, because if you haven't defined any subscriptions, then it basically says, don't send me anything at all, right? So you don't find that it suddenly changes behavior when you turn it on. You actually have to define a subscription before any data flows. And then if I configure metric collection, will the cluster be bombarded with metrics? Well, no, it won't again, because the default interval for doing these things is every 5 minutes. So you're going to get each client which has been asked for metrics will by default send metrics only once every 5 minutes. So it's quite a gentle flow, okay? Now, if you've gotten a massive cluster and you've turned on all metrics for all clients under the sun, you would get a lot of data. So don't do that. This is for troubleshooting, right? Rather than for, to see how much CPU you can burn, because you probably could burn a lot if you tried really hard. And then finally, can I disable it for a specific client? You can. It's on by default, but there's a configuration to turn it off for a particular client. So if you have one which is really high performance and you're just not interested in this, you can turn it off for that client. But if you're that kind of user, it's possible that you don't want to use it for that cluster at all. So you just don't install the plugin, right? This is the kind of general purpose utility use of Kafka for people where the owner of the cluster is different from the owner of the client. So, it's got a specific kind of target market, and that's what it is. So let's talk a little bit about the required and standard metrics. So the purpose of this is to enable metrics from different client libraries to get kind of brought in together. Because we have people who write, Python applications that use client and, that use clients, and .NET applications that use clients, and Java applications. Now the Java ones almost all use the Apache Kafka client. The other ones they can use, well, a lot of them use libRd Kafka or something built from libRd Kafka, but there are other kind of Golang clients as well. We want to be able to have metrics from all of those coming in together. Now, admittedly, you need to have the client libraries implementing support for 7.1.4 to do this, but the KIP says how you should do this and what you should offer up as your metrics if you're kind of doing a cross-platform thing. So there are two kinds of metrics defined in the KIP. One is called required metrics, and that basically says if you are supporting KIP 7.1.4 and the concept makes sense, you must support this metric. Okay, so there are only 6 required metrics at the moment, and they are, there are 3 for producer, 3 for consumer, number of connections created, and the latency maximum and average. That's it. Okay, so nothing to do with buffer pools or rebalances or all that kind of stuff, because you find that the implementation details of the clients are actually quite different. So there aren't that many concepts in common, but the basic flow of communication data is common across all clients, and it is reasonable to have required metrics like that. And then there are standard metrics. So these are still conceptually to do with Kafka rather than the implementation of the particular client, but it's still more debatable. So if you were, you kind of get a choice with those ones whether you implement them, but it does at least define what it means to send one of the standard metrics. And then it's completely free beyond that, right? So any metric which is not in this list, you can send to the broker, provided it's within a subscription. And because of the way the naming works, you can actually go outside the Apache Kafka namespace and send other metrics as well. So let's talk a little bit about the naming. So I showed a little snippet of the documentation earlier where we had these things called mbean names with these funny compound names with mbeans and tags and all this kind of stuff. A little bit difficult to understand, and it's a multi-part name. Now, when we made the decision to use OpenTelemetry, OTLP, well, it has opinions about naming as well, right? And the names in OTLP or in OpenTelemetry are, multi-part hierarchical linear names, like a same style as a Java class name, something like that, right? So it was important to come up with a naming convention that worked with OTLP and made sense and didn't rename everything under the sun. So what we have is each metric in Kafka actually has kind of 2 names now, and they're algorithmically related to each other. You can map one to the other in a totally predictable way. So the Kafka metric names are mbean names, and then the telemetry metric name is the name that you use when you're doing KIP 7.1.4. So I'll talk quickly about one of the examples. So this connection creation rate group producer metrics, that's the top of the table. When that is used in KIP 7.1.4, it's called org Apache Kafka producer, because that's the producer metrics part of the name, and then it's called connection creation rate, and the hyphens have been replaced with dots. So you end up with just kind of a linear dotted name. And you'll see that when you start browsing these things in one of the tools, It also means if you combine the metrics from a variety of places, it might be Kafka and a database and a network card or something all into a single metrics platform. The fact these start org Apache Kafka means we don't clash with anything else, so it's safe to combine them into a bigger thing without making a mess. Okay, so the way this is done is quite thoughtful. And then the final kind of piece of this is the client metric subscriptions. So this is how you control which metrics are sent by which clients. And as I said, you probably don't want to ask everyone for everything because you're going to get a lot of stuff. But if you have a kind of a targeted idea of what you're trying to sort out or what you're trying to solve, then this is quite a powerful thing. So it has this idea of a client metrics configuration resource, and that's the thing you're manipulating with the Kafka client metrics tool. And it has only three attributes at the moment. Metrics, which is the list of metric names, and they are prefix matched, okay? So if I do org Apache Kafka producer, then I get every producer metric, but I can hone it down. I could do org Apache Kafka consumer rebalance if I wanted all the rebalance metrics. So you can have a wide or a kind of a fine net for your metrics with this. And it's a list, so you can have A, B, C, D if you want a certain handful of metrics. And you can define several of these, and they can overlap or be separate from each other, and you get kind of the union of all these things. When you have multiple of them defined. You can also control the interval that the data is sent by. So every 5 minutes is at fault. And finally, match criteria. So this is saying which clients this particular thing matches. Okay, so you could, for example, say, I want just the Python clients. So the way I would run this in practice is I would probably run with a very, very small number of metrics for a lot of clients. And if I'm trying to solve a particular problem, I would hone in on the troublesome client, and I would give it a very, very targeted subscription, probably with a shorter interval, so I can dig into a problem, and then I would delete that thing when I've understood it. Okay? So it's really for troubleshooting in that kind of scenario. Let's give a couple of examples. So this example is, let's say I want the latency metrics for every client on my cluster. So Kafka client metrics, name is latency, I'll give it any name I like, and the metrics attribute is org Apache Kafka producer node request latency, and org Apache Kafka consumer node request latency. So it's going to pick up the latency metrics for producers and consumers. Okay? But that'll work for every single client that connects to the cluster and supports CLIP 714. So that's quite a broad selection of clients, but a tiny number of metrics. So let's look at another one. This one is a rather different shape. So this is metrics is org Apache Kafka consumer. So that means send me every metric from the consumer. Interval of 60,000, that's 60,000 milliseconds. So that's once every 60 seconds, it's going to send the data. And now it has match in this case. So it says client software name is Kafka Python. And the client software version is 1.2. With some backslashes in there in order to escape it. So that will take every consumer metric from any Python 1.2 client every 60 seconds. So you can get them really fine. And you can do it by client ID, for example. If you have, I want all the payroll applications to send metrics, no one else, you could do that. You can even do a particular client, just one specific client, because they have an ID for each particular client, and you can put that in as the match if you just want a particular client to send the data. Cool. So now you're going to notice the tricky part of this is, and that is, does Apache Kafka come with a plugin? No, it doesn't. It doesn't come with a plugin, right? And the reason it doesn't come with a plugin is, well, you need a metrics backend, and everyone uses a different backend, and we can't put a dependency on Apache or from Apache Kafka onto another project, which we don't know whether people use or not. It kind of doesn't make sense to do that. So there isn't a plugin actually that comes with Kafka, but we have a tutorial which gives you the source code for doing the plugin. So you can take it, and we're going to show a demo of that in a minute. So if you follow the QR code, then it'll go to the tutorial. If you like kind of documents, then you can go to the top link, the developer Confluent one. If you're a curly braces person like me, there's a GitHub one instead. You can go and see the source code. Okay. But remember, if you're writing one of these yourself, you need to think about several things. Where are you going to put the metrics? How are you going to view them? How are you going to alert them? And then for a busy cluster, you might get a lot of data. So can I cope with the load? where are you going to store it if you've got enough storage, and then cardinality is the last thing, okay? And that means how complicated are the metrics, because they identify themselves client by client, so it's actually quite a kind of a broad data set, essentially. So I'm going to hand over to Apoorv now, who can show you it in action. So if you'd like to explain that on the way through as well.
Yeah, for sure. Let's see this in live action. So what we're going to do is, like, first we're going to see the plugin. Like, this is a basic plugin which does nothing much, but whatever metrics broker going to receive, it's going to transmit it over a gRPC endpoint. So by default, we're going to use the 4317 endpoint. Couple of things the plugin has to do. It has to implement a metrics reporter interface. What does that mean is that, in Kafka, it specifies that which all classes are responsible for emitting metrics which it can receive. The other thing which it has to do is, like, it has to implement an interface which is called client telemetry. This is a new interface which has been introduced in KIP 714. This interface tells broker that there exists a plugin which can receive these metrics which are received by the broker and can forward it somewhere. So we go down in this particular class, it does very simple job. It just reads the metrics received by the broker, appends some labels which have been fetched from the context itself, and export it over a gRPC endpoint. That's pretty much it too. Other things are just logs. So for the demo, what we're going to do is, like, we're going to see this particular thing running on a Kafka server. And when these metrics are received, they transmit it to a gRPC endpoint. So we need a collection where we can collect it. So for that thing, we're going to use an OTel telemetry collector, which is an OTel collector. And the configuration for it is plain simple. It says, like, the collector going to receive the metrics on 4317 endpoint, and it's going to export over to a Prometheus endpoint. The additional thing we have done is, like, we have added a namespace, which is KIP-714, so that we know these metrics are going through a route of OpenTelemetry collector. And the last bits are, like, just send the, whatever the attributes or the labels have been received on the broker, send it to Prometheus as well. So if I go to my terminal, and here I'm going to start my Docker Compose. This Docker Compose is going to go do two things. It's going to start my OTel collector, and the other thing, it's going to start my Prometheus endpoint. So yeah, it does two things. I go back to my UI and see on Prometheus, see if any of the KIP 714 metric comes. There isn't any yet, because we haven't started the Kafka broker, we didn't start the client, and we do not have the subscription. So the other thing what we need to do is, like, we need to copy the built binary which is generated in this tutorial itself. Once you build it, and those steps are there in tutorial itself, that binary you have to copy somewhere in libs in Kafka. And that exists over here. For the demo, I just copied it before. And in terms of the configuration, you have to go forward and specify there exists a plugin which should be responsible for sending the client telemetry data. I switch my terminal. On the extreme left, I'm going to be starting with the Kafka server. In the middle, in the blue, we're going to be seeing the producer in action. And on the right, in the green, we're going to be seeing the consumers. And we're going to be seeing, like, how these metrics flow. So if I start my Kafka server, server has been started. One of the things which Andrew mentioned is, like, the clients, if they come up, they need to have a subscription. And that subscription tells them, like, which metrics they can push. So two things I do over here. I go forward and create a topic. I create a single topic, which is like KIP 714 demo, and it has a single partition. The next thing I will do is, like, I will create a subscription, which is send all some metrics. So here in this subscription, on the black in the left side, you can see I'm specifying that the metrics I require is one of them is, like, records and total. And for the demo, I am keeping the interval as 10 seconds so that we see these metrics quickly. Once I do that, I can see the things have been configured on the broker. I start my console producer, and I am going to produce on the same topic that I have created. I produce some records, say 5 records. If I go forward and open my JConsole and attach this producer over there, then we should see some metrics like this. And one of them should be records and total, and which is at value 5. Now, if I go back to my UI, where my Prometheus is running, I just refresh it, and I search for KIP714. So the metric starts appearing. So what happened in the background is the client asked the broker that, do we have any subscription, or does KIP714 is enabled? So the broker, because the plugin has been registered, it says like, yes, there exists one, and this is the subscription. And that subscription tells like which metrics to push and what should be the interval. That's where the client starts happening. It started collecting the metrics and sending it to broker. If I see this metric and plot a graph of it, I can see the value is coming as 5, and there appears to be some labels. These labels would be the data which has been sent by the client itself. That could be console producer as the client ID. Client instance ID is the one which uniquely defines every particular client running, and this has been added in KIP714 as well, so that you can uniquely determine what the client is. It adds some other attributes as like what's the SDK you are running on, what's the version, and how this particular metric, what's the cluster ID of the Kafka is. Now these all, the labels are the one where you can have a matching criteria, and you can be very specific in terms of which client to send which metric. I go back to my terminal, and now this time I allow all metrics. So there exists a wildcard where you can say asterisk, which means any metric which can be ever collected, you should go forward, the client should go forward and send it to broker. There's an additional subscription has been created in the broker. Now, what happens in the background is the client, when it goes forward for the next push interval, it sees like the broker determines that there has been change in the subscriptions. It recomputes the subscription and sends it back to the client. So the client in the next interval can send the aggregated list of the new metrics. One of the other things which we have to note about over here is like, what about new metrics? If there are certain new metrics in Kafka clients that has been added, do we need a constant churn in terms of adding those things for KIP714? We not. Any metric which can be reported over GMX console can be reported to KIP714 as well. So for that particular thing, I would be showing up not a regular consumer, but something called share groups. The share groups are the thing which is being introduced, which is going to be introduced in Kafka 4.0, which is about if can you consume from a single partition cooperatively using multiple consumers. So what I do over here is like I create 2 consumers. One, they are in the same group. One is SD1 and the client ID is share consumer 1. They are reading on the same topic where we have produced previously. The moment I start it, it should consume all the messages which I have produced previously. On the same topic, within the same group, I'm going to start another consumer, which is the share consumer 2. It should not start consuming anything because there is no data over there. So what happens in a single partition in a regular consumer groups, that if there occurs multiple consumers, then only a single consumer read from a single partition at a time. But the things which are going to be changed from Kafka 4.0 when share groups are introduced, you can cooperatively consume from a single partition, having like multiple consumers, where you can horizontally scale them. I add some data. So what I'm doing is I'm asking Kafka producer perf test to generate some data on KIP714 demo topic. The record size would be 6 bytes, and the number of records should be 1,000. The moment I do it, I can see the consumption is parallel on both of the sides of the consumer. I produce a couple of more. So in total, I think I produced 3005 messages. If I go back on my Prometheus UI and I refresh it, then I see a lot of metrics. One of the important things we have to note over here is that the producer would be also sending all the metrics now, but I haven't restarted my producer client. So producer client on the runtime, they determine which additional metrics or which fewer metrics we have to push. I see one of the metric that I have for the consumer I have done is like record total, and I execute it. And I can see a parallel consumption going on. In total, there would be this consumer read around 952 messages and the other read around 2053. And these two are well differentiated in terms of the attributes they are coming up, where the client ID has been different altogether. If I produce more, you're gonna see like the consumption gonna be much in line and much cooperatively shared, rather than we see the consumption on a fewer number of messages could be bit not evenly distributed. So that's something with the demo. I think I continue back to the slides. Hand over to Andrew.
Okay, thank you. I'm going to have to jump to a different slide, right? That one. So let's just recap how that worked, okay? Exactly the same as we were talking about before, except then the blue tutorial client metrics plugin, that's the plugin which Paul showed you the source code for, okay? And it sends data using gRPC to this thing called the OpenTelemetry OTel collector. So this is a standard kind of component that understands OTel, and it knows how to send data into Prometheus. Prometheus then has a UI, and we looked at the metrics in the UI. So this would be a fairly basic, kind of open source way of doing KIP 714. Okay? So let's talk very quickly about what next. So there is another KIP called KIP 1076, and this gives applications the ability to add their own metrics. Okay? Now, you could do it for your own applications. Okay? You could have, com.acme.payroll metrics. That would work. But really, it's for Kafka Streams, okay? Because Kafka Streams clients include producers and consumers, and then they have metrics about how they're being used together. So this allows the metrics to be extended for Kafka Streams. But you could use it for any extension tool if you wanted to. And it is approved. The code is still being written, but it's intended to be in Apache Kafka 4.0. So this kind of completes the picture for KIP 714 from the point of view of the Kafka clients. And then one potentially more interesting one is, what about metrics which are kind of distribution-based in nature? So something like latency, right? Where you'll find that there's a kind of, you've got a kind of a curve which has a long tail, and you're trying to work out what proportion of metrics are over a particular threshold. Well, Kafka metrics, client metrics, don't know how to do that at the moment. So what we're thinking of is extending it to support histograms, and then extending KIP 714 kind of technology in order to support histograms as well. So you'll be able to get distributions and find out, 50% of the latencies were under, 50 milliseconds or whatever, right? That'll be really quite useful for trying to analyze some performance problems. And that will take another KIP, and we're still kind of in the, thinking phase of that, I would say. So let's summarize it. You can use KIP 714 with an entirely open source stack, which is what we showed, including Apache Kafka. You will need Apache Kafka, I recommend 3.8 or later. You'll need some modern clients, so 3.8 for later for Java, and libRd Kafka-based ones of 2.5.3 or later. You'll need a broker plugin, and we've shown you where you can get one of those to get started with, and a metrics backend, such as Prometheus, or maybe one of the more complicated ones if you've got one at your disposal in your organization. Okay.